3 years ago today, the President was here in an empty high bay, challenging us to go to an asteroid by 2025. Today, this is a world-class production facility with a flight article, a flight vehicle, Orion, getting ready to fly next year. We've made tremendous progress in our transition to the future. And now with the announcement during the budget rollout last week of our plans to retrieve an asteroid and send a crew to it, we're moving forward to meet the President's challenge. And this is not the only area that we've made tremendous progress in over the last 3 years. Out at Launch Complex 39, we're readying Pad B, High Bay 3 in the Vehicle Assembly Building, the LCC, to meet our commitments to be ready to launch the Space Launch System in 2017. We've come this far and we've made this much progress because of the tremendous NASA contractor team and the cooperation between Johnson, Marshall, and Kennedy Space Centers as we move forward. But rather than listen to me talk about it, I want to bring the experts up here and let them tell you about the progress that we made and where we're going. First up, Dan Dumbacher from the Exploration Mission Systems Director at headquarters. Dan?
Thank you, Bob, and good afternoon, everyone. And again, welcome to the hardware. NASA is very excited with our budget rollout from last week that you have seen to retrieve an asteroid and send a crew to it to explore that asteroid and return samples. We have lots of work ahead of us on that challenging and complex mission. We have to learn how to do solar electric propulsion. We have to figure out how to detect asteroids of the size that we want to retrieve and explore. And we have to build the capabilities to get the crew to the asteroid. And what you see behind us is an example of that wonderful progress that has been made by the Orion team. There's also great progress by the Space Launch System team, getting the launch vehicle ready, getting the crewed spacecraft prepared, and all the ground systems that we need to process and launch those vehicles. So you see an example of that hardware behind you. We are thrilled with this mission. We are looking forward to it. It will be a challenge. It will be complex. But NASA's up to the challenge, and the team that you see represented here is ready and willing to take it on. With that, I'd like to introduce Mark Geyer, our Orion Program Manager, and he can talk about his hardware.
Hey, thank you for coming today. Welcome to the Orion factory. I'll talk a little bit about the vehicle behind me in a minute. First of all, I wanted to say that this architecture, this Orion SLS ground ops architecture, is extremely capable, very flexible, and so I think this is another great example of that, this asteroid mission. We worked together with the folks who are starting to plan this mission to understand exactly what the capabilities are needed, and so Orion and SLS fit very well into this plan. We'll work through the rest of the summer to identify the details as we go through the specifics, but we already know that these systems can meet the challenge of this new mission. As you know, many of the core systems that you need for any mission, regardless of where you go, we're going to test on EFT-1, which flies in a mere 17 months in September of 2014. We'll test the heat shield, the guidance navigation, the parachutes, avionics. We're going to go 3,000 miles into space. We're going to go about 84% of lunar entry velocity to test the heat shield. And again, that's happening just in a few months. So behind us is the flight article for EFT-1. It's in a stand that we're going to use to test. We're going to do a static loads test, so we'll pressurize it, and we have actuators that will push on the structure to simulate liftoff, to simulate parachute deploy, to simulate the other big loading tests to make sure the structure behaves as we expect. And then we'll finish the outfitting, put the boxes in, cables, weld the tubes and everything else, and then send it out to the pad. So the team here is doing a great job, and the factory, of course, is right here at KSC, and you're in it at the moment. So we are now building, testing. In 14 months we'll be flying, and we're also now planning new and exciting missions. So it's a great day to be part of ESD and part of Orion. So now I'm going to introduce Keith Hefner, who's the Space Launch System Program Planning and Control Manager.
Good afternoon. The Space Launch System capability is essential to America's future in human spaceflight and exploration of deep space. Only with a heavy lift launch vehicle can humans explore our solar system, investigate asteroids, and one day set foot on Mars. With respect to the Exploration Flight Test 1, it will be able to help us in the SLS program reduce our risks with respect to providing early information on our vehicle stability, guidance, navigation, and control, environmental loads, and many other factors that will help us in our design as we move forward. The Orion stage adapter is currently being designed and built at Marshall. It will be used for multiple flights, not only for Exploration Flight Test 1, but also for Exploration Mission 1 and 2, as a part of our pursuit of providing affordable solutions for human spaceflight. With respect to progress that we're making on SLS, the SLS team has met all of its milestones and its objectives. We're moving forward toward our vehicle preliminary design review this summer. With respect to the other elements on SLS, we have large tools needed that have been bought and put in place at the machine assembly facility down in New Orleans, including what is one of the largest welding tools that has ever been built. The J2X engine team has tested a selected laser melted or 3D designed part that will ultimately prepare us for putting the first such part on our first flight in 2017. Also, the J2X is in the test stand at Stennis now. Once that testing is completed, then we will be moving forward with the RS-25 testing for that engine in the same test stand. Our 5-segment booster team is currently looking toward a qualification test or a qualification motor later this year. With all of this said, and in summary, the Space Launch System program is on course to deliver the national capability for beyond Earth orbit exploration beginning in 2017, and later to take our astronauts into outer space and ultimately to Mars. Now I'd like to introduce Scott Colorado from the Ground Systems area.
Thank you. As Keith said, I'm with the Ground Systems Development and Operations Program. I have the job of essentially figuring out what Kennedy Space Center is going to do in the future and in the past to make sure that we're ready to support the rocket and spacecraft that they've described, the Space Launch System and the Orion. As we are here today, 3 years ago, we really hit the ground running, trying to make sure that we would be ready for the program facing us, both EFT-1, Exploration Flight Test 1, as well as exploration missions beyond that. I think you'll find we've made a lot of progress. Again, I'm with the Ground Systems Development and Operations Program. It's here at Kennedy Space Center. Our job is to make sure that the assets that you're mostly familiar with, I would think, like the vehicle assembly building, launch pads, shuttle landing facility, assets like that. Our job is to convert those from what they used to do, primarily a space shuttle program, to get ready for the new exploration missions. So we're well on our way of doing that. It was kind of a concept in most cases 3 years ago. Moving forward, now it's becoming reality. One of the things we've done is taken a very flexible approach. We know that missions change, launch vehicles evolve, spacecraft evolve, and we want to make sure that we're ready as those items change, we can change with them. So what you'll see here at Kennedy Space Center is a very flexible, evolvable approach. So as the missions are defined and as the commercial or government users materialize, we're ready to accept them. Just to walk you through a few things that we've touched on, some of the major assets. For example, Launchpad 39B, if you haven't been out there recently, we've done a major overhaul there. We've pretty much cleaned the pad up. We call it a clean pad concept, where it is able to accept various users potentially, in addition to SLS, which is our primary mission. The lightning protection towers have been created to create a universal lightning protection system, as opposed to one that was dedicated for shuttle, like you would see at Pad 39A today. So we've made some major progress there. We've also revamped the cryogenic systems, the fuels, commodities, things like that. The ramp that goes up to the pad has gone through an overhaul itself. So all sorts of systems have been changed to get ready for the next generation of spacecraft. We've also done a lot of work on the VAB, primarily the high bays that you may be familiar with the Space Shuttle program. We're now converting those from a space shuttle configuration. The platforms and ground support equipment, the things that you would see there under shuttle have now been removed, and they're currently in the design of putting in new flexible platforms and ground support equipment that would be able to evolve not only to support SLS, but other programs as well. We've also in the midst of building a mobile launcher, similar to the Space Shuttle program, where the mobile launcher is a big steel structure that's used to actually interface with the rocket in the VAB. It's picked up and taken to the pad. That system has been designed and for the most part built. We're in the midst of designing the changes to convert that to an SLS capable mobile launcher. And we also have the crawler transport. I think a lot of people are familiar with, where the crawler is being upgraded from a 12 million pound capacity to about an 18 million pound capacity, which will be able to pick up the mobile launcher and take that to the pad with the Space Launch System vehicle on board. A few others, we also are doing the Orion hazardous processing in a facility here in the industrial area called the MPPF, the Multi-Purpose Processing Facility. That construction will happen this year. And the Launch Control Center. The Launch Control Center, we've overhauled Firing Room 1, that old Space Shuttle firing room, and now it's being converted for SLS. So we're making sure that's ready, along with the command and control system that's being outfitted to have that ready for SLS as well, in Orion. And finally, the last system is here at Kennedy and Ground Systems Development Operations. We have the role to recover the crew module, both for EFT-1 and beyond that. And we're working on that as well to be ready to recover when they splash down. So I think that's all I have. And the only thing I would mention is, again, it was 3 years ago that we were put on this mission, and since then we've come up with the architecture to support it. We've come up with these assets, redefined our architecture to support the program that we're working on now, and we're well on our way to making that happen. And I think we'll take your questions now at this time.
Hi, Peter King with CBS Radio News, and I've actually got a couple questions for both Mr. Geyer and Mr. Hefner. And questions for each of you would be, have the biggest challenges so far in getting this done been financial or technical? And if you can get specific but in layman's terms, thank you.
I have to choose, huh? So I think, let me say this, there are clearly technical challenges in integrating these systems to get this capability in the vehicle and the requirements that we have on a schedule we've been given. Both the reliability, mass, and schedule have been a real challenge. Part of that is, I think, again, reinvigorating the supplier base across the country. We use tens of suppliers. In one case on the heat shield, we used I think 14 different titanium suppliers across the country. So it's a struggle to get that done and get it done on time. And also, though, as a benefit is that there's suppliers across the country learning how to build these parts for spacecraft, which I think is important for the country and its competitive edge. So I think that's been a real challenge. The budget is a challenge really because it's a flat budget, to be straightforward. We don't get the normal DD. If you know, the development curve usually goes up and then you ramp off. I understand what the budget is today and the challenges that we have as a country. So we have a flat budget. That means that we have to develop some systems and then ramp off and develop the other ones. So it causes some strategies we have to work through and gapping some of those teams, if you know what I mean. They move on to other parts of the company or onto other things, and then we may need them back when we come back and we're done with these other systems, and sometimes it's hard to ramp up enough to do that. So I think the budget has definitely been a challenge as well, but we recognize that's part of the job. It's not just going to an asteroid, it's also doing it affordably and meeting the constraints that we can do. So I hope that answered your question.
I would say on the SLS side, we try to use many of the same hardware elements that were carried over from the shuttle program, that being the boosters and the RS-25 engines. We do have one new element, that being the core stages. So I would say, challenge-wise, I would say it's the integration of those various elements within SLS, as well as the integration of SLS with the other program elements outside of us, with Orion and PCV, and of course with the ground systems area. And the other big area, as Mark mentioned, is our budget. We are looking at and having to deal with a flat budget for the budget horizon. horizon period. So being able to pull off all the technical elements that have to be done within the schedule constraints that we have within that fixed budget is definitely a challenge for us.
Just one brief follow-up. This is either for Mr. Cabana or